Hello viewers. To solve problems in artificial intelligence, we need to represent the agents and environment in the form of state space representation. To know what is state space representation, you are welcome to Rain Computer. State space representation consists of initial state, goal states, and the states involved and space. Initial state is the state where it starts from. The goal state is the destination state. The states is a set of sequence of steps between initial and the goal state by applying set of rules. And the space is a set of all possible states in between the initial and the goal state. Search, a technique which takes the initial state to the goal state by a set of valid rules while moving through space of all possible states. We call that as the search. So state space representation is a set of all possible states for a given problem. How it can be represented? A search tree. It can be represented in the form of a tree or graph. Now we are going to look into the search tree representation. A tree representation of the search problem is called the search tree. The root of the search tree is the root node, which is corresponding to the initial state. Whereas the actions, it gives the description of all available actions to the agent. Transition model, a description of what each action do, can be represented as a transition model. Path cost, it is a function which assigns a numeric cost to each path. For example, in the traveling salesman problem, from the initial starting place to the end place, we can go by different directions or different path. The cost involved for each path that we need to calculate so that we can get the optimal solution. Solution is an action sequence which leads from the start node to the goal node. It can be anything, but it should reach from start to the end. That is a solution. But the optimal solution is the lowest cost among all the solutions. We call that as the optimal solution. The terminologies that are involved in this representation are the search. Searching is a step-by-step procedure to solve a search problem in a given search space. A search problem can have three main factors: a search space, a start state, and the goal state. Search space represents a set of possible solutions which a system may have. The start state is the state from where the agent begins the search. Goal state is a function which observes the current state and returns whether the goal state is achieved or not. This is how the search algorithm is going to work. The properties that we need to consider for a search algorithm are listed here: the completeness, optimality, time complexity, and the space complexity. A search algorithm is said to be complete if it guarantees to return a solution, if at least any solution exists for any random input, then it is complete. Optimality, if a solution found for an algorithm is guaranteed to be the best solution. As I said in the traveling salesman problem, it could be the lowest path cost among all other solutions. Then such a solution for us is to be an optimal solution. Time complexity is a measure of time for an algorithm to complete its task. It is for the algorithm time. Space complexity, it is the maximum storage space required at any point during the search as the complexity of the problem. So the storage space is required for the finding the goal state, that during the search algorithm, that is the space complexity. So the time consumed for the search algorithm from initial to final state is called the time complexity, and the storage space required to arrive the desired location is called the space complexity. How the search algorithms are classified? They can be classified either uninformed search or as informed search. The uninformed search does not contain any domain knowledge. It only includes the information about how to traverse the tree and how to identify the goal nodes. Uninformed search applies a way in which search tree is searched without any information about the search space. Whereas in the informed search algorithm use domain knowledge. In an informed search, problem information is available which guide the search. Informed search strategies can find a solution more efficiently than an uninformed search strategy. Informed search is also called a heuristic search. A heuristic is a way which might not always be guaranteed for the best solution but guaranteed to find a good solution in reasonable time. Informed search can also can solve much complex problem which could not be solved in other way. An example of informed search algorithm is the traveling salesman problem. Types of search. Uninformed search can be divided into five main types. Breadth first search, uniform cast search, depth first search, iterative, and bidirectional search. So these can be represented, we are going to represent these in the tree structure. In informed search, it can be greedy or A-star search. So these are the classifications we have in the uninformed and informed category, and we are going to look into the properties of these search in our future videos. Hope you like this video. Subscribe to get updates from our channel. Thanks for watching.